Assalamualaikum warahmatullahi wabarakatuh. My name is Nurbatisha Binti Effendi and I am presenting for our group in a title Reverse Engineering Mathematics Assignment. In these group members, we have Ahmad Syamil bin Muhammad Muslim as a project manager and me myself, Nurbatisha Binti Effendi as a chief executive, Nur Izzidaha Binti Mazli as a senior engineer and Abdul Muhammad Farmi as a engineer. So for introduction, Celcom Telecommunication Company has received a project to build a communication pole in an area. The correct position of the telecommunication pole is necessary to ensure that the signal is well received. Therefore, a study needs to be conducted by our company for the construction of the communication pole. The investigation has been done using two methods such as Green's theorem and direct theorem. The investigation using Green's theorem is being used to prove that the Green's theorem is the same as the direct method.
Assalamualaikum and good evening. My name is Nur Izzidaha Binti Mazli. As a senior engineer, first of all, I want to say thank you to Nurbatisha for your presentation. And now I will explain about Green's theorem. What is Green's theorem? Green's theorem is used to integrate the derivative in a particular plane. If a line integral is given, it is converted into a surface integral or the double integral or vice versa using this theorem. Okay, let R be a simply connected plane region whose boundary is a simple, closed piecewise smooth curve C oriented counterclockwise. If fxy and gxy have continuous first partial derivative on some opposite contained in R, then the equation is given integral C fxy dx means differentiate to dx plus gxy dy differentiate to dy equal to double integral R bracket delta g over delta x minus delta f over delta y to dA. Next, given the question and transmit signal of C1, C2 and C3, also the value of coordinates C1, C2, C3. Given the question, which use Green's theorem to find the work done by the signal transmitted from telecommunication pole to other telecommunication pole on a particle that move along straight path. If the signal is equal to fxy equal to x power of 2y plus x power of 3, 4x minus 1, and C is over the triangle formed by the lines y equal to 0, x equal to 1, y equal to 2x in counterclockwise direction. So given the formula is work equal to integral fxy to dA. So I will pass to Abdul Muhammad Farmi to present the solution of Green's theorem. Thank you.
Thanks for the presenter just now. Hi, Assalamualaikum. My name is Abdul Muhammad Farmi. I will continue how to get the solution using Green's theorem. For the first step, we must sketch the triangle using the instruction in the question have given. So the instruction given is y equal to 0 for part 1, x equal to 1 for part 2 and y equal to 2x for part 3. From sketching, we also can calculate the gradient using the formula y equal to mx plus c and also can get the limit for our double integral. After sketching, we can continue our solution is declare the fxy and gsy. From the question given, we must calculate the work done by the signal using Green's theorem. The formula is counter integral f capital letter xy dA also can simplify in counter fxy dx plus gsy dy or using the double integral region del g per del x minus del f per del x dA. We also must determine the value of the del g per del y and del f per del x by the differentiation the value. After differentiation, we put our value in the formula double integral. Just now, I also explained how to get the limit from sketching. So, the limit can be determined in our sketching. We must put the constant is our parallel and not parallel is our region. So, 0 to 1 is our x and 0 to 2x is our y. So, we can solve this question. That's all for me. Thank you.
Thank you, Fahmi, for the presentation. Assalamualaikum, my name is Ahmad Shamil and I will continue to answer the Green's theorem question. From the slide we can see the integration limits 0 to 1. Open bracket 4 times 2x minus x squared times 2x close bracket minus open bracket 4 times 0 minus x squared times 0 close bracket ds. We simplify the equation and we get the integration 0 to 1 ax minus 2x power of 3 dx. Next, we integrate the equation respect to x. We get ax power of 2 over 2 minus 2x power of 4 over 4. The limit is 0 to 1. We simplify the equation. We get 4x power of 2 minus x power of 4 over 2 close bracket 0 to 1. We insert the limits into the equation. We get 4 times 1 power of 2 minus 1 power of 4 over 2 close bracket minus open bracket 4 times 0 power of 2 minus 0 power of 4 over 2 close bracket. We simplify the equation and then we get 4 minus 1 over 2, and finally the last answer is 7 over 2. Therefore, this question can be solved using Green's theorem to find the work done by the signal transmitted by the telecommunication pole. Proceed to this slide. We're using MATLAB to draw the position of the triangle of the telecommunication pole. The first is we type the coding and then we get the triangle shape. The position of telecommunication pole, the first is 0, 0, net is 1, 0, and the last one is 1, 2. We use this triangle to easily to answer the theorem, Green's theorem question. The last slide is the conclusion of the result. Based on the result that we have used the Green's theorem to answer the question, the answer is only short calculation because the Green's theorem involves the double integral formula Green's theorem, and we need to know the limits of the double integral. Rather than the direct method, it have a long calculation. We need to know each path of the triangle, and we can prove that we get the same answer, 7 over 2. That's all from us, and I hope that you will understand what we have explained. Thank you.